Okay, this is question number 39, and it's question number 39. It's given that we hold a concave mirror in your hand and direct its reflecting surface towards the sun. So this is the concave mirror whose reflecting surface is curved inwards, and direct the light reflected by the mirror onto a white cardboard held close to the mirror, and move the cardboard back and forth gradually until you find a bright, sharp spot of light on the board, which is the image of the sun. So this spot of light is the image of the sun on the sheet of the paper, which is, and the point at which we get the image of the sun is the principal focus of the concave mirror. Now, we have to list two applications of concave mirror. So, uh, uh, to give two applications of the concave mirror, we know the concave mirrors are used where you want to magnify or see something as magnifying image. So it's used in torches to get parallel beams of light. So these are used in torches and in the searchlights that you might have seen above the walls, installed on walls of the jail, the walls of the jail to throw a powerful beam of light, parallel powerful beam of light. So these are used in torches, these are used in searchlights, these are used in vehicle headlights. And all these vehicle and all these three cases, torches, searchlights, and vehicle headlights, they are used to throw a powerful parallel beam of light. And they are also used in shaving mirrors to closely see your face for shaving so that you can get a close shave. They are also used as dentist mirror to see the bigger image of the teeth or the cavities. They are also used in the solar furnaces to concentrate the sunlight and to raise the temperature of the furnace, because the if you concentrate the sun rays, the sun rays have infrared rays, and that helps us in generating heat or raising the temperature of the furnace. So these are, you have to give any two applications. I have listed five or six here. You can give any two of these. So for part B, it's given that if the distance between the mirror and the principal focus is 15 centimeter, find the radius of curvature. So this distance between the mirror and the principal focus, mirror means the pole. So distance between the pole and the principal focus is the focal length. So this is a concave mirror, so its focal length is 15 and radius of curvature is the double of the focal length. So 2 into 15 is equal to 30 centimeter. I'm not using the sign convention. So the radius of curvature is 30 centimeter for the mirror, which is double of the focal length. And we have to draw a ray diagram to show the type of image formed when object is placed between pole and focus of a concave mirror. So let's draw a ray diagram. And this is a concave mirror. So let this be a concave mirror. Let this be the pole. Okay, let me draw it once again. Let this be the pole of the concave mirror. This is the non-reflecting surface. And the reflecting surface is curved inwards. And let's move the pole. Let this be the principal axis that passing through the pole. And the center of curvature, let this be the center of curvature. This be the principal focus. Now the object is placed between the pole and the focus. So we know we always denote the object and it's always upright. So arrow should be pointing upwards. This is the object. Okay, and this is the ray that is going parallel to the principal axis, and the ray parallel to the principal axis always, after reflection, always goes through the focus. Okay, this is all right. Now we have to consider one more ray. So let's say this is the ray. So let this be the ray that is incident obliquely on the principal focus. So it will follow the law of reflection and it will be reflected obliquely such that the angle of incidence is equal to the angle of reflection. This is the angle of incidence, this is the angle of reflection. Now these two rays are intersecting. Okay, this is, so these two rays are intersecting here. Uh, but let me not take this one. Okay, so this is one ray that is passing. This is incident obliquely on the pole, and let me take one ray such that let this be the ray. Okay, it is incident. This ray is incident here. Okay, let this be the ray that is incident. It's a magnet. Okay, now let this ray be incident at 90 degree on the concave mirror. So this will retrace its path and will come back as it is. Okay, this be the ray. Okay, this ray goes like this, comes back, so it retraces its path. So it comes like this. Now, where will be the image form? Now, we have to extend these rays here. So, and let's mark them with a dotted line because these are not the actual rays. These are seems to be intersecting when produced backwards. So these seems to be intersecting here. So this is the point where these rays are intersecting, and this is the image formed, which is denoted by A dash B dash, and it's erect, so the arrow should be pointing upwards. So the image formed is virtual because it's not formed by the actual intersection of the rays. It's formed when we assume that the rays are intersecting when produced backwards. Okay, now, so this is the ray diagram. It was also only to draw the ray diagram and make sure that you give the direction for the rays because that will uh, deduct half your marks if you're not showing the direction of the rays. So the ray diagram is drawn. Now, moving on to part C, an object 10 centimeter in size. So C part. So the object size is denoted by H and it's always upright. So height is 10 centimeter is placed at 10 centimeter in front of a concave mirror. So 10 centimeter is the object distance denoted by U, and it's always negative because it's in front of the mirror, and all the distances are measured from the pole, and its distance is opposite to the direction of the incident ray. So this is negative 100 centimeter. If its image is formed at the same point where the object is located. So the image is formed at the same point where the object is located. So that means the image distance is also 100 centimeter. So image distance is also 100 centimeter. And because it's formed at the same point where the object is located, so it's also negative. Okay, now we have to find the focal length and we are going to use the mirror formula. So using mirror formula. So mirror formula is 1 upon V plus 1 upon U is equal to 1 by F, which gives me 1 upon negative 100 plus 1 upon negative 100 is equal to 1 by F. So this is negative 100 and negative 100 is equal to 1 by F, which is minus 2 by 100 is equal to 1 by F. So F is equal to negative 100 by 2. So this is equal to negative 50 centimeters. So focal length is 50 centimeter. And negative indicates that it's the concave mirror. Okay. So what is the next part? Okay, we have find the focal length and now the magnification of the image formed with sign as per sign convention. So magnification of the image form. Now the magnification is given by negative V by U and it's negative for the formula. V is negative 100, this is negative 100 and magnification is negative 100. So, sorry, yes, magnification is negative 1. Negative 1, negative means that the image is, this is negative 100, sorry, negative 1. Sorry for that. This is negative 1. So magnification is negative 1. We have to find that in terms of, so 1 means that the image size is equal to object size and Negative means that the image is inverted. So negative sign indicates negative indicates that image is inverted. So this is the case when the object distance and image distance are equal. Don't compare this case with this ray diagram. This ray diagram is when the object is between the center of curvature and the focus. And this is when the image and object are at the same distance. So here the focal length is 50 centimeter. That means that the image and the object are at the center of curvature. So negative sign indicates that image is inverted, and one means image size is equal to object size. Okay, with this, we are done with this section, this part, and with this paper code 3111 for 2023. Do like, share, subscribe. Thank you for watching.